I'm going to go ahead and do the odd numbered problems on here. I'd like you to try the even ones on your own and then check your answers. I'll do videos for those as well, but check your answers on those after we go ahead and go through the odd numbers here. So we have the difference of the logs, which means we have the log of a quotient, and the log of a quotient now gives us log on one side, number on the other. We want to unlock the variables, so we rewrite in exponential form. So we have 8 equals x over x minus 1, multiplying both sides by x minus 1 gives us 8x minus 8 is equal to x. Subtracting x from both sides, we get 7x. Adding the 8 to both sides, we get 7x equals 8. Dividing by 7, we get x equals 8 over 7. Number 13, we've got the sum of the logs, and when we have the sum of the logs, we take the log of the product. So we have log base 8 of the product of 2 and x squared plus 7 is equal to 2. Our variable is locked up in the log, so we're going to unlock that by writing in exponential form. 8 squared equals 2 times x squared plus 7. 8 squared is 64. We want to go ahead and distribute the 2 to both terms. We get 2x squared plus 14 equals 64. If we subtract 14, we get 50. Divide that by 2, we get 25. So we get x squared equals 25, and we get x equals plus or minus 5. Now, here's the thing. We always want to check to make sure that, and we didn't do that in the last one, check to make sure our answer that we get makes whatever we're taking the log of a positive number. So 8/7 is positive there. 8/7 minus 1 is still positive. So I want to make sure we check. I forgot to do that. Sorry. Plus or minus 5, you think, oh, x is negative, so it doesn't work. Well, that's not true. It's if whatever you get for x makes whatever you're taking the log of 0 or negative, then we have to throw it out. But as long as whatever you get for x makes what you're taking the log of a positive number, then you're okay. So both negative and positive 5, when we square them, give us a positive 25, and so therefore what we're taking the log of, x squared plus 7, will always be a positive number. And so that checks out as well. 15. Difference of the logs means we have the log of a quotient. So the first log comes first, x plus 2 comes first, over x minus 3 is equal to 1. We rewrite this using exponents. We're going to multiply both sides by x minus 3 to get rid of the fraction. We're going to distribute the 7. 7x minus 21 equals x plus 2. We're going to subtract x from both sides, we get 6x. If we add 21 to both sides, we get 23. So we get x equals 23 over 6. And that doesn't necessarily look right, but yeah, that's right. And if I replace x with 23 over 6, which is bigger than 3, it works in both of the expressions up there. So yes, 23 over 6 is in fact the correct solution. And then finally, number 17, we have the same base, 2 logs on the left side, the difference of the logs, which means we want to take the log of the quotient. The log of the quotient is log of 7 over 4x plus 5 is equal to 1. Our variable is locked up in the log, so we want to unlock that by rewriting using exponents or exponential form. When we multiply both sides by 4x plus 5, we get this, and then we're going to go ahead and distribute the 2 to both terms. 8x plus 10 equals 7. And then when we subtract 10 from both sides, we're going to get 8x equals negative 3. And then when we divide both sides by 8, we get x equals negative 3 over 8. So negative 3 over 8, this is a little bit trickier here. If we replace x up here, 4 times negative 3 over 8 minus or plus 5, is that greater than 0? So that's the question. 4 goes into 8 2 times, and so we get negative 3 halves plus 5. So yes, that is indeed greater than 0, so we're done. And we just put a box around it. So there you go. Go ahead and try the even numbers, and then and you can check the next video. You can fast forward even through the next video and see if you get the answers right. If you don't, then rewind for the explanation.